my advice for you, I asked myself, what would Einstein say? And it occurred to me that Einstein, being an intelligent fellow, knowing how to give talks, would probably start with a joke. And fortunately, I happen to know Einstein's favorite joke. It turns out to be quite relevant. So here it comes. A man is having trouble with his car. It frequently stalls. So he goes to a garage and asks them to fix it. They replace the transmission and put in new spark plugs, but his car still doesn't run right, so he takes it to another garage. At the second garage, the mechanic pokes around for 10 minutes, then pulls a screwdriver out of his belt and tightens a screw, and now the car runs perfectly. But the man is irate when he gets the bill in the mail for $200. This took place in the 1950s, and that was a lot of money. He storms back to the mechanic and says, "This is outrageous. All you did was tighten a screw, and you asked for $200. I want an itemized bill." And so the mechanic takes out a pad and pencil and writes down an itemized bill. And this is what it said. Labor, turning screw, $5. Knowing which screw to turn, $195. So my first piece of advice is to consider very carefully the possibilities for what you can do before choosing. This principle works on several levels. You should consider many different possibilities for what general sort of work you want to do before settling into one. And when you have finished one project, you should think about many different possibilities for what to do next. And when you encounter a problem, you should consider various possible approaches before investing in any one. It's easy to give vague advice, but I'm going to break new ground for a talk like this and give you an algorithm. Many of you are probably thinking about getting married. And naturally, you'd like to maximize your chance of finding the best possible mate. So I'll give you an algorithm for that. So first you have to estimate the number n of suitors that you can expect to deal with over your career in courtship. Okay. Now we'll assume that you evaluate them one at a time, and that once you've broken up with one, then that one is gone forever. Okay. Then what you should do with this is this, if you want to maximize your chance of getting the very best suitor. Evaluate, but do not accept each of the first n divided by e suitors. Here, e is a number, the base of natural logarithms, about 2.7. And then accept the first subsequent suitor who is better than all the other ones, all the earlier ones. Okay? So now that you got them calibrated. And that is mathematically how to maximize your chance of getting the best possible mate. So for example, if n is 10, then you should evaluate but reject each of the first 4 suitors and accept the first one after that who is better than them. In my own case, I estimated n equals 3. And I dutifully broke up with my first serious girlfriend, but the second was better and I married her. and that worked out fine. Of course, the precise assumptions that underlie this particular algorithm might not always be appropriate, but the underlying lesson is much more general. You should put considerable effort into gathering information before choosing what to invest in. The great mathematician Henri Poincaré, when asked how he came up with such good creative ideas, responded, "I generate a lot of ideas and discard most of them." And that is also nature's trick in natural selection. My second piece of advice is to learn about the history of your endeavor. And this has many advantages. By reading masterworks, you come in contact with great minds and get to feel how they operate. Often the original works are well expressed, and you can learn valuable expressions about how to express yourself. Valuable lessons about how to express yourself. Most important, you can begin to see yourself and your work as part of a continuing narrative. A story that started before you entered and that will continue after you leave. And that's a beautiful thing to realize.
I think that deserves an applause.
Oh, thank you. So that's that was my advice to students. Okay, now I really do want questions. All right.
Have you always been in physics in your studies?
No, I guess, and followed my own advice before I knew it, which I thought about many things. Before I went to college, I thought I might, well, I really thought I would probably study neurobiology. I wanted to know how the mind works. I was very influenced as a child and a teenager by Bertrand Russell and thinking about philosophy. But I realized philosophy as such was kind of not the best way to find out the truth. And so I intended to study neurobiology. But then when I actually went to the University of Chicago and started to study neurobiology, I found out it was about kind of working with these smelly, messy little objects and very painstaking work that I was not well suited for. I didn't like it. And what I really liked was mathematics, and at that time, certainly neurobiology wasn't ready for mathematical treatment, really. At least not the questions I was interested in. So I didn't really know what to do at that point, but I had always had wide interest. I read the Feynman lectures as they came out and so forth. But I decided to put off the decision exactly what to do. I majored in mathematics because that I could do easily without spending a lot of time in laboratories, and it gave me a lot of time for exploration. And so I majored in mathematics and even got my degree in mathematics. Then went to Princeton to graduate school in mathematics. But fortunately for me, I didn't know exactly what I wanted to do. I wanted to apply mathematics to something, but I didn't know what. But fortunately for me, at Princeton, the mathematics building is attached to the physics building. And it was very natural to wander over to the physics building, and I went to seminars, and I found out that very exciting things were happening in physics at that time. There were a lot of new ideas about quantum field theory and normalization group, symmetry, the kind of things I had been interested in mathematics, symmetry especially. And so it was very natural to get involved, and that's what I did. And never looked back. I mean, I found out that I was good at physics, and it was very interesting. So I stuck with it. And but within physics, I've done different things too. I mean, originally my original focus was particle physics and quantum field theory, and I've of course continued to be interested in that. But when I went to Santa Barbara, to that new institute, then new, the Theoretical Physics Institute at Santa Barbara, its strength was really condensed matter physics. And I got very interested in that too. Got involved in applying methods of quantum field theory to condensed matter. Found some interesting things about how charges can break up, electrons can break up into smaller things, and then there's been a fantastic development over the last 25 years or so that are investigations of the very smallest objects and the highest energies at accelerators and in what's called high energy physics turn out to be profoundly important for cosmology, for the study of the universe as a whole, because this structure of the universe at present is largely determined by what happened in the early times near the Big Bang. And near the Big Bang, the energies were very, very high, the temperatures were very, very high. So it's important to know how matter interacts in those extreme conditions. And it's been very fruitful to apply what we know about, what we've learned about high energy physics to cosmology. And so I've been involved in that too. So. I think physics is inexhaustible, and I hope eventually, actually, I've sort of been tending, but I haven't actually done any, made any real contribution, but I'm sort of tooling up to go back to these problems of how the mind works, and using the mathematical tools and that I've acquired, and also, you know, the subject has really changed from when I was an undergraduate. There's much more known, much more powerful techniques. So I think it might be ripe for real theoretical treatment. Finally. So it's a case study in kind of keeping an open mind.
So did you know that you were going to win the Nobel Prize? Were you saying this is going to win me one, or were you just?
Yes, I didn't know, but I actually, while we were doing that work, which realized that if it was right, that is, if nature really chose to work this way, that we had figured out one of the main problems of physics. There are four forces in nature, basically. There's electromagnetism, gravity, the weak interaction, and the strong interaction. And after decades of frustration, we really had figured out, or we had a candidate for how the strong interaction worked that you could actually use, and it was very pretty. And the question was whether nature chose to work this way. That I was much less sure about. But I thought that if the experiments indicated that it was the way, then I thought we would, especially for the last few years, because a prize for the experimental work that verified our theory was given fairly recently. So I thought that then it was really coming. So every October for the last 5 years or so, or for the 5 years preceding the award, I had gotten very nervous, and when it was knowing the announcement was going to come, and I couldn't sleep the night. And this year was like that. I mean, 2004 was like that. So I wasn't able to sleep, and I kept looking at the clock. I knew that the announcement would be 6 a.m. Eastern Time, which is 12 o'clock Stockholm time. And I thought if it were going to happen, they wouldn't call until then. They called after the official announcement. So at 5 o'clock, I decided to get up, because I wasn't sleeping, and take a shower. Sorry,